on site is progressing quite nicely. We opted for a modular construction strategy, essentially taking the full bridge and breaking it out into Lego-sized blocks. Why? Because it's really a question of speed. So when you're prefabricating pier segments or fabricating steel elements off-site in a factory or in a shop, well, you get a better component.
The piers act as the legs of the bridge. They allow to transfer the load from the superstructure to the footing. Each pier varies from 3 to 8 segments, weighing each at 65 to 70 tons. The highest pier closest to the cable stay bridge has a height of 35 meters. So the pier caps are the 2 V sections that are connected in the middle. They allow to transfer the load from the superstructure to the pier legs. We have 37 pier caps on the new Champlain Bridge, and each pier cap weighs around 400 tons.
So the West approach is very much a marine-based operation on the river itself. So the prefabricated pier leg segments arrive on site. Essentially, we have to move them to the correct location on the river, where we have a crane on a barge, which essentially picks up the pier leg segments and then essentially installs them one on top of another to create the full elevation. We often refer to them as being Lego-sized blocks, with one very important difference. They fit in a very specific spot in the project, so they're not interchangeable.
It takes approximately 2 to 3 weeks to install a pier leg with its pier cap. Pier caps are installed in 2 stages. The second stage is our last opportunity to be able to modify or rectify anything that needs to be done to the bridge. It's our last phase. We have to make sure everything's bolted correctly and everything's on the duct. Everything has to be perfect. We definitely have a lot of challenges working on the water, specifically when you have to erect pier caps with a single crane with the given space that we have, and you have some complex maneuvers to do over the water.
Operating on the river involves essentially working on maritime barges. The river itself is very wide, not very deep, a very strong current, strong winds. And essentially all this involves many complex operations tasks, working at height, working on water. So one of the first things we need to do for each of these tasks is to actually do a risk analysis. And this is done in full collaboration between the construction teams and the health and safety teams. Why? Because in the bottom line of all of this is health and safety is priority 1 on this project.
I came to Montreal to do my Master's of Engineering, which helped me propel my career in bridges. So I'm proud and happy to be able to give back to Montreal and Quebec what it has given me, and to be able to build a landmark bridge and give back to the community.